Hello everyone, my name is Shagun Dhingra. Today, me and my teammate Abhishek will present our paper Recommender System Evaluation, a quantitative literature review. The agenda of this presentation will start with the overview of the recommender system. Then we will discuss about the different approaches of the recommender system and also an overview of the deep learning and some of the state of the art in the recommendation system. Finally, we will discuss about the open challenges and the future work in this field. During the last few decades, with the rise of YouTube, Amazon, Netflix, and many other such web services, recommender systems have taken more and more place in our lives. From e-commerce, where suggestion is provided bias for articles that could interest them, to online advertisement, where suggestion is provided to users for the right contents, matching their preferences. So recommender systems are totally and unavoidable in our daily routine journeys. In a very general way, recommender systems are the algorithms aimed at suggesting relevant items to users, where the items being movies to watch, text to read, products to buy, or anything else depending on the industries. So recommender systems are really critical in some industries as they can generate a huge amount of income when they are efficient or also be a way to stand out significantly from competitors. As a proof of the importance of recommender systems, we can mention that a few years ago, Netflix organized a challenge, the Netflix Prize, where the goal was to produce a recommender system that performs better than its own algorithm with a prize of $1 million to win. In this presentation, we will go through different paradigms of recommender systems. For each of them, we will present how they work, describe their theoretical basis, and discusses their strengths and weakness. So first is collaborative filtering methods. So these methods are for recommender systems that are based solely on the past interactions recorded between users and items in order to produce new recommendations. These interactions are stored in the so-called user-item interaction matrix. Then the main idea that rules collaborative methods is that these past user-item interactions are sufficient to detect similar users or similar items and make predictions based on these uh, estimated proximities. Next is a model based and the memory based. So the class of collaborative filtering algorithms, it is divided into two subcategories that are called memory based and the model based approaches. So memory based approaches directly works with the values of recorded interactions, assuming no model and are essentially based on the nearest neighbor search. Let's have an example. Find the closest users from a user of interest and suggest the most popular items among these neighbors. So the model-based approaches assume an underlying generative model that explain the user item interactions and try to discover it in the order to make new predictions. So let's firstly discuss the memory base. So the main characteristics of memory base is that the user and item approaches is that they use only information from the user item interaction matrix and they assume no model to produce new recommendations. In order to make a new recommendation to a user method roughly tries to identify the users with the most similar interactions profile, that is nearest neighbor, in order to suggest items that are the most popular among these neighbors and that are new to our user. This method is called user-centered as it represents user based on their interactions with items and evaluate distances between users. Assume that we want to make a recommendation for a given user. First, every user can be represented by its vector of interactions with the different items, its line in the interaction matrix. Then we can compute some kind of similarity between our user of interest and every other user. That similarity measure is such that two users with the similar interactions on same items should be considered as being close. So once the similarities to every users have computed, so we then can keep the k nearest neighbor to our user and then suggest the most popular items among them. To notice that when the computing similarity between the users, the number of common interactions, that is how much items have already been considered by both the users, so that point should be considered carefully. So indeed most of the time we want to avoid that someone that only have one interaction in common with a reference user could have 100% match, and it will be considered as being closer than someone have 100 common interactions and agreeing only to the 98% of them. So we consider that two users are similar if they have interacted with a lot of common items in the same way. We can have an example similar rating or similar time hovering. Next is a model base. So to make a new recommendation to the user, the idea of item method is to find the items similar to the ones the user been already positively interacted with. So the two items are considered to be similar if most of the users that have interacted with both of them did in the similar way. So this item is said to be item centered as it represents items based on the interactions users had with them and evaluate the distances between those items. Assume that we want to make a recommendation for a given user. So first we consider the item this user liked the most and represented by its vector of interaction with every user. Then we can compute similarities between the best item and all the other items. So once the similarities have been computed, we then can keep the k nearest neighbors to the selected best item that are new to our user of interest and recommend these items. So here is one point to notice that in order to get more relevant recommendations, we can do this job for more than only the user's favorite item and consider the n preferred items instead. So in this case, we can recommend items that are close to the several of these preferred items. So next is the content-based methods. So the model-based collaborative approaches, they only rely on user item interaction information and assume a latent model supposed to explain these interactions. So for example, matrix factorization algorithms consist in decomposing the huge and sparse user item interaction matrix into a product of two smaller and dense matrices. So a user factor matrix containing users representations that multiplies a factor item matrix containing item representation. The main assumption behind matrix factorization is that there exists a pretty low dimensional latent space of features in which we can represent both the users and items, and such that the interaction between the user and an item can be obtained by computing the dot product of corresponding dense vectors in that space. So unlike collaborative methods that they only rely on the user item interactions, so content based approaches use additional information about users or the items. So let's have an example. Uh, in the movie recommender system, this additional information can be, for example, the age, the sex, job, or any personal information for users as well as for the category, the main actors, the duration, or the other characteristics for the movies. So then the idea of content based is to try to build a model based on the available features that explain the observed user item interactions. Still considering users and movies, we will try, for example, to model the fact that young women tend to rate better some movies than young men tend to rate better some other movies, so and so on. So if we manage to get such a model, then making new predictions for a user is pretty easy. We just need to look at the profile like age, sex, or any personal information of that user, and based on that information to determine the relevant movies that we can suggest. So the third approach is a hybrid approach which combine content-based and collaborative filtering methods in order to mitigate the limitation of each other. So the item cold start problem refers to when the items added to the catalog have either none or very little interactions. So this constitutes a problem mainly for the collaborative filtering algorithms due to the fact that they rely on the items interactions to make recommendations. So if no interactions are available, then a pure collaborative algorithm cannot recommend the item. So in case only a few interactions are available, although a collaborative algorithm will be able to recommend that, but the quality of those recommendations will be very poor. So this arises another issue, which is not any more related to new items, but rather to unpopular items in some cases. So for example, movie recommendations, it might happen that a handful of items receive an extremely high number of interactions while most of the items only receive a fraction of them. This is referred to as popularity bias. The new user case refers to when a new user enrolls in the system and for a certain period of time, the recommender has to provide recommendation system without relying on the user's past interactions since none has occurred yet. So this problem is of particular importance when the recommender is a part of service offered to the users, since a user who is faced with the recommendations of poor quality might soon decide to stop using the system before providing enough interaction to allow the recommender to understand his or her interests. So the main strategy in dealing with the new user is to ask them to provide some preferences to build an initial user profile. A threshold has to be found between the length of user registration process, which if too might long.
Hi, my name is Abhishek, and from here onwards, I will present the rest of the paper. The number of research publications on deep learning based recommendation systems has increased exponentially in the past recent years. There was a rise in metric factorization after 2003 with the Netflix prize, where they announced a competition that could beat their own algorithm. In particular, Rexis started to organize regular workshops on deep learning since 2016. For example, in the 2019 conference in Copenhagen a couple of years ago, there is a whole category of papers on deep learning which promotes research and encourages application of such methods. Four key strengths of deep learning recommendation systems compared to that of traditional content based and collaborative filtering approach will be highlighted in this slide. The first one is the nonlinear interaction. Deep learning can model the nonlinear interaction in the data with nonlinear activations such as ReLU, sigmoid, tanh. This particular property makes it possible to capture the complex and intricate user item interaction patterns. Conventional methods such as matrix factorization and factorization machines are essentially linear models. It is well established that neural networks are able to approximate any continuous function with arbitrary precision by varying the activation choices and combinations. This property makes it possible to deal with complex interaction patterns and precisely reflect the user's preference. Deep learning can efficiently learn the underlying explanatory factors and useful representation from input data. In general, a large amount of descriptive information about items and users in available in real-world applications. Making use of this information provides a way to advance our understanding of items and user, thus resulting in a better recommendation. Deep learning is a powerful tool for sequential modeling tasks. In tasks such as machine translation, natural language understanding, speech recognition, etc., RNN and CNN play a critical role. They are widely applicable and flexible in mining sequential structure in data. Modeling sequential signal is an important topic for mining of temporal dynamic of user behavior. For example, next item, basket item prediction, and session based recommendation are typical application. As such, deep neural network become a perfect fit for many sequential pattern mining tasks. Deep learning also possesses high flexibility. There are many popular deep learning frameworks nowadays, including TensorFlow, Keras, Caffe, PyTorch, etc. These tools are developed in a modular way and have active community and professional support. The good modularization makes the development and engineering a lot more efficient. Based on our survey, we have categorically classified different deep learning approaches in recommendation system. Let us discuss each one of them and some of the state of art. Multi-layer perceptron-based recommendation is a feed-forward neural network with multiple hidden layers between the input layer and the output layer. You can interpret MLP as a stack layer of nonlinear transformation, learning hierarchical feature representation. It is concise but effective network that can approximate any measurable functions to any desired degree of accuracy. One of the most popular model using this approach is wide and deep learning. As you can see from the figure, wide and deep learning is a nice model that can solve both regression and classification problems that are introduced for app recommendation in Google Play. The wide learning component is a single layer perceptron, which can be regarded as a generalized linear model, while the deep learning component in MLP um, is an MLP. Combining these two learning techniques enable the recommender to capture both memorization and generalization. Autoencoder is the unsupervised model attempting to reconstruct its input in the output layer. In general, the bottom layer is used as a salient feature representation of the input data. Architecturally, the form of autoencoder, as shown in the figure, is a feed-forward neural network having an input layer, one hidden layer, and an output layer. The output layer has the same number of neurons as the input layer for the purpose of reconstructing its own inputs. This makes an autoencoder a form of unsupervised learning, which means no label data as necessary. Almost all variants can be applied to the recommendation task. Autoencoder can be used to fill in the blanks of user item interaction metrics directly in a reconstruction layer. Various models like AutoRec, collaborative denoising, autoencoder, and multi-VAE and multi-DAE have used this capability of autoencoder. Convolution neural network is a feed-forward neural network with convolution layer and pooling operations. It can capture global and local features, thus significantly enhancing the model's efficiency and accuracy. It is powerful in processing unstructured multimedia data. In recent years, graph convolution networks have proposed models graph and seen success on various recommendation system benchmark. However, these gains on benchmark tasks have yet to be translated to gain in real world environment. Therefore, a highly scalable GCN framework that was developed and deployed in production at Pinterest. Some of the key features of this framework was on the fly convolutions. The second one was the constructing convolution via random walks. And the third one is efficient map reduce inference. The other category is recurrent neural network. Now, RNN is suitable for modeling sequential data. It has loops and memories to remember former computations. Variants of RNN include LSTM and GRU, and they are deployed to overcome the vanishing gradient problem. RNN can deal with temporal dynamics of interactions and sequential patterns of usual behavior in session-based recommendation task. GRU4rec is a session-based recommendation task where um, where the input is the actual state of the session of one of n encoding and where n is the number of items. The coordinate will be 1 if the corresponding item is active in the session, otherwise 0. The output is the likelihood of being next to the session for each item. The next category is restricted Boltzmann machine-based recommendation. According to the inventor Geoffrey E. Hinton, a Boltzmann machine is a network of symmetrically connected neuron-like units that makes stochastic decisions about whether to be on or off. Now, Boltzmann machines have simple learning algorithm that allows to discover interesting features in datasets composed of binary vectors. The learning algorithm is very slow in networks with many layers of feature detectors, but it can be made faster by learning one of the feature detectors at a time. A RBM is a specific type of Boltzmann machine which has two layers of unit As illustrated in the figure, the first layer consists of visible units and the second layer consists of hidden units. In the restricted architecture, there are no connection between units in a layer. The visible units in the model correspond to the observed component, and the hidden units represent the dependency between the observed components. The goal of this model is to jointly probability of is the goal of this model is a joint probability of visible and hidden units. Because there are no connection between hidden units, the learning is effective as all the hidden units are condition dependent, giving the visible units. Attention models are differentiable neural architects that operate based on soft content addressing over an input sequence or an input image. They are motivated by human visual attention and can filter on the uninformative features from the raw inputs and reduce the side effect of noisy data. This attention mechanism is ubiquitous in computer vision and NLP domains. In the context of RS, we can leverage the attention mechanism to filter out the not noisy content and select the most representative item while providing good interpretability. Now, attentive collaborative filtering uses an attentive collaborating filtering model with a two-layer of attention mechanism inside a latent factor. The model consists of an item level and an component level attention, where the item level 1 selects the most representative item to characterize uses, and the component level captures the most informative features from the auxiliary information for each. Now, some other categories we found in deep learning based recommendation system are neural autoregressive, which is an unsupervised neural network built on the top of an autoregressive model and feed forward neural network. Deep reinforcement, which is a combination of deep neural network and reinforcement learning formula. Adversarial generative neural network, which consists of a discriminator and a generator, where these two neural networks are trained simultaneously by competing with each other in a mean max game framework. Now, as we have gone through the overview of the taxonomy of different deep learning based recommendation system, now let us some of the future work and open challenges in this field. A common observation in deep learning is that it's difficult to perceive the hidden weights and activation. Deep learning is still considered as a black box, and it seems to be very difficult challenge to provide explainable predictions. At present, non-interpretable concerns of neural models have been more or less eased by attention models. Moreover, attention models have contributed to greater degrees of interpretability, if nothing more, as the attention weights can not only offer information on models' inner mechanism, but can also offer users with explainable outcomes. Given the fact that models are now able to emphasize what contributes to the preferences, we believe this is the next frontier of the research. There's other important factor which is called deeper network. Now it has been seen that the performance have been improved with deeper neural network, and this is something that should be explored more. Currently, many major corporations sell consumers different goods or services. Single domain recommender system concentrate only on one domain while ignoring user preference in other domains, and therefore will not be best fit to these companies. They also face the problem of sparsity and cold start. A cross-domain recommendation system which can facilitate recommendation from the knowledge learned from the diverse domain would be more suitable to these big companies. Finally, the last challenge observed is the lack of benchmarking of all the models. Wherever a new model is proposed, it is evaluated and compared against several baselines. The choice of baselines and datasets used for the evaluation are arbitrary in most of these cases. As such, there is an utmost requirement for a benchmarking tool that can evaluate and compare these models. This paper presentation reflects our survey and reviews the existing literature on deep learning based recommendation system to help new researcher and build a comprehensive understanding of the field. Thank you for your patience. If you have any question, don't hesitate to contact us.